Examples: numerical solution to algebraic and transcendental equation. Example number 1, find real root of the equation f of x is equal to x cube minus thrice x plus 1 in the interval 1 to 2, correct up to 2 decimal places using bisection method. So here solution, here f of x is equal to x cube minus thrice x plus 1, and here interval given 1 2, that is f of 1 is here, f of 1 is equal to 1 minus 3 plus 1, that is minus 1, which is less than 0, and f of 2 is equal to 8 minus 6 plus 1 3, which is greater than 0. Now since f of 1 into f of 2 is less than 0, and therefore root lies in the interval, lies in the interval 1 to 2. So now step first, we select here a is equal to 1, b is equal to 1, b equal to 2, and this implies h is equal to, or c is equal to b minus a divided by 2, that is 1 b, a plus b divided by 2, not b minus, it is a plus b divided by 2. So 1 plus 2 divided by 2 is equal to 1.5. Now we want to determine sine of f of 1.5. So f of 1.5, now the given function is x cube, so it is 1.5 cube minus thrice x, so 1.5 x cube minus thrice x plus 1, so plus 1, so it is equal to, if we simplify this, it is equal to minus 0.125, and which is less than 0. Now from previous step, f of 1 is less than 0 and f of 2 is greater than 0, and root always lie between positive and negative. So here it is negative, means what, in the previous interval the f of 2 is positive. Now since f of 2 into f of 1.5 is less than 0, and therefore for the next interval our root lies in the interval 1.5 to 2. In the first step our root lie in the interval 1 2, and for the second step, after first step, the root lies in the interval 1.5 and 2. So the interval length reduces. Step number 2, again here a is equal to 1.5, b is equal to 2, c is equal to a plus b divided by 2, so it is 1.5 plus 2 divided by 2, so it is equal to 1.75. and if you find the sine of f of 1.75, is equal to, now the function is 1.75 x cube minus thrice x plus 1. So if we simplify this, it is equal to 1.1094, and which is greater than 0. From the previous step, in the last interval, f of 1.5 is greater than 0, 1.5 is less than 0, and f of 2 is positive. So now since it is a positive, in the last interval f of 1.5 is negative. Now since f of 1.5 into f of 1.75 is less than 0, and therefore root lies in the interval for the next iteration, our root lies in the interval 1.5 and 1.75. Now the next step number 3, take a is equal to 1.5, b is equal to 1.75, and c is equal to 1.5 plus 1.75 divided by 2, which is equal to 1.625. Now f of 1.625 is equal to, now again it is x cube, so 1.625 x cube minus 3 times 1.625 plus 1. So if we simplify this, it is equal to 0.416, and again it is greater than 0. Now f of 1.75 is also greater than 0, and this is also greater than 0. So in the last interval, f of 1.5 is less than 0, and therefore for the next iteration our root containing an interval is f of 1.5, and f of 1.625 is less than 0, and therefore by location root theorem our root lies in the interval 1.5 and 1.625. Now for the next interval, for the next step number 4, a is equal to 1.5, b is equal to 1.625, and c is equal to 1.5 plus 1.625 divided by 2. So it is equal to, c is equal to 1.5625. Now if you find the sign of f of 1.5625, that is equal to x cube, that is 1.5625 cube minus thrice x, that is 1.5625 plus 1, then it is equal to, this is nothing but the 0.1272, and which is greater than 0. Now since it is a greater than 0, again in the last step this is a positive and f of 1.5 is negative. So for the next iteration our root lies in the interval, since f of 1.5625 is less than 0, for the next iteration our root lies in the interval 1.5 and 1.5625. So iteration number 5, step 5, a is equal to 1.5, b is equal to 1.5625, and c is equal to 1.5 plus 1.5625 divided by 2. So it is equal to 1.5312. And if you find f of 1.5312, it is equal to 1.5312 cube. Function is what? X cube minus thrice x, 5312 thrice x plus 1. So it is equal to, if you solve this, it is minus 0.000034. Now so again it is less than 0, and in the previous interval this is a greater than 0. Now since f of 1.5312 into f of 1.5625 is less than 0, for the next interval, for the next root, our root containing an interval is 1.5312 1.5625, and therefore now in the next step number 6, okay, a is equal to 1.5312 and b is equal to 1.5625, and c is equal to, here c is equal to a plus b, that is 1.5312 plus 1.5625 divided by 2. If we solve this, c is equal to, we get 1.5469. So again since the value of c is 1.53 and 1.54, they are carried up to 1 decimal places, so we want to determine again f of c. So it is f of 1.54. We want our root should be carried up to 2 decimal places. So it is equal to x cube, that is 1.5469 x cube minus thrice x 1.5469 plus 1. So it is equal to 1.54, it is 0.06 0608, which is greater than 0. So again, in the last interval, from these two, f of 1.5312 is less than 0, 5312. So f of, in the last step, f of 1.5312 into f of 1.54, sorry, 5469 is less than 0, and therefore root lies, for the next interval our root lies in the interval 1.5312 and 1.5469, and therefore x is equal to, for the next step number maybe, and next step is what, step number 7. For step number 7, a is equal to 1.5312 and 1.5469, and therefore c is equal to 1.5312 plus 1.5469 divided by 2. So it is equal to 1.5319. Now you can see here the previous root, the value of c is 1.54, here 1.5319. So again we want to determine one more step. 1.5319 is equal to 1.5319 cube minus 3 times 1.5319 plus 1, so it is equal to 0.0284, which is greater than 0. And the last step, what is again 1.5312 is less than 0. So f of 1.5319 into f of 1.5312 is less than 0, and therefore for the next interval our root lies in the interval, for next iteration is 1.5319, 5312 small value, and 1.5319. So if you now for the next step number 8, here a is equal to 1.5312 and b is equal to 1.5319, then c is equal to 1.5312 plus 1.5319 divided by 2, then it is equal to here 1.5352. Now you can see here the value of c, c is 1.5352, and for the previous step it is 1.5319. so these are correct up to 2 decimal, the successive two values of c are correct up to 2 decimal places, and we want our answer should be correct up to 2 decimal places. So here answer is what, 1.53. This is the answer of the given equation, correct up to 2 decimal places. Now next example, example number 2. Find a real root of the equation. Find a real root of the equation x cube minus 9x plus 1 equal to 0 in the interval 2 to 4 using false position method. Again here f of x is equal to x cube minus 9x plus 1, and f of 2 is equal to, here f of 2 is equal to 8 minus 18 plus 1. So this is equal to 8 plus 9 minus 18 is minus 9, and f of 4 is equal to 4 cube, that is 64 minus 36 plus 1 is equal to root lie between 2 and 3. sorry, 2 and 4, sorry, here 2 and 3, make changes here, 2 and 3. So f of 3 is equal to 3 cube, that is 27, minus 27 plus 1 is equal to 1, which is greater than 0. So this is less than 0, it is 3 is greater than 0. Now since f of 2 into f of 3 is less than 0, by location of root theorem, our root lies in the interval, root of the given equation lie in the interval 2 to 3. Now step number first, now we are going to apply false position method to find the root of the given equation. So here a is 2, b is 3, f of a is equal to minus 9 and f of b is equal to 1. So c is equal to a f of b minus b f of a divided by f of b minus f of a. So it is equal to a f of b, so it is equal to 2 into 1 minus b f of a, 3 into minus 9 divided by f of b minus f of a, that is 1 minus minus 9. So if we simplify this, the value of c is equal to 2.9. Okay, now f of c is equal to f of 2.9. the given function is, what is given, x cube minus 9x plus 1. So x cube is 2.9 cube minus 9 times 2.9 plus 1. So it is equal to minus 0.711, which is less than 0, and now in the last interval, that is in 2 to 3, f of 2 is less than 0 but f of 3 is greater than 0, and root always lie between one positive and one negative. Since this is a negative, f of 2.9 is negative and f of 3 is positive, and therefore now since f of 2.9 into f of 3 is less than 0, and therefore root lies in the interval, so our root lies in the interval 2.9 and 3. So step number 2, here a is equal to 2.9, b is equal to 3, f of a is equal to 2.9 is minus 0.711, and f of b is equal to, by f of b, that is f of 3 is what? F of 3 is 1. So now again, if you find c is equal to a f of b, that is 2.9 a f of b 1 minus b f of a minus 0.711 divided by f of b minus f of a. F of b is what? 1 minus f of a minus 0.711. So c is equal to 2.9416. 2.9416. Now this is the value of c is equal to 2.9416. now if you compare this value of c with the previous value of c, you can see here these two roots are correct up to, two values of c are correct up to 1 decimal places, but we want our answer should be correct up to 3 or 4 decimal places. So for that we want to determine next step. For that we want to determine f of c is equal to f of c is equal to f of 2.9416 and f of x is equal to x cube 2.9416 x cube minus 9x 2.9416 plus 1, and if we simplify this, f of c is equal to minus 0.0215, which is less than 0. F of c is less than 0, and in the previous step, what is here, f of a is less than 0 but f of b is greater than 0. So here again, f of 2.9416 and into f of what is here, f of b. F of b is what? F of 3 is less than 0, and therefore our, for the next iteration, our root lies in the interval 2.9416 into 3 and 3. So now step number 3, here a is equal to 2.9416, b is equal to 3, and f of f of a is equal to minus 0.0215, and f of b is equal to 1. F of b is what? 1. So now c is equal to a f of b. So 2.9416 a f of b minus b is what? 3, f of a minus 0.0215 divided by f of b minus f of a, that is f of b is what? 1 minus f of a minus 0.0215. If we simplify this, c is equal to 2.9428. Now here c is equal to 2.9428. Here the value of c, in the previous iteration, what is the value of c here? C is 2.9416 and here 2.9428. So you can see here these two roots are carried up to 2 decimal places. Now if you take one more iteration, for that f of c is equal to f of 2.9428 is equal to x cube 2.9428 cube x cube minus 9x 2.9428 x cube minus 9x plus 1. So here f of 2.9428 is equal to minus 0.0006, and again which is less than 0. So now f of a is less than 0 but f of b is what? Greater than 0. So again, for the next iteration, our root lies in the interval 2.9428 and 3. So now if you take one more iteration, see step number 4 here, with a is equal to 2.9429, b is equal to 3, c f of a is equal to minus 0.0006, and f of b is equal to 1. F of b is what? 1. So if you find here, try to find here c is equal to a f of b. So 2.9429 a f of b 1 minus b, that is 3 f of a minus 0.0006 divided by f of b minus f of a. F of b is 1 minus f of a minus 0.0006. So it is equal to, c is equal to 2.9428. Now you can see here 2.9428 here. 28. Okay, you can see here what is the value of c here? 2.9428 in the last iteration, and here it is also 2.9428. that is, these two roots are carried up to 4 decimal places. So answer is what? 2.9428. This is the value of x which satisfy the given equation. Now next example number 3. Example number 3. Find a real root of the equation. Find a real root of an equation x raised to 5 plus 5x plus 1 equal to 0 using Newton-Raphson method. Newton-Raphson. So here f of x is equal to x raised to 5 plus 5x plus 1. Now first we want to determine root containing an interval. Now if you f of x is equal to first if we try from f of 0 is 1, f of 1 is equal to 1 plus 5 6 6 plus 1 7, then x here, and f of minus 1 here, f of minus 1 is equal to minus 1 minus 5 plus 1, so it is equal to minus 5, which is less than 0. So you can see here now, since f of 0 is greater than 0 and f of minus 1 is less than 0, and therefore our root, that is x, always lie in the interval 0 to minus 1 to 0, sorry, minus 1 to 0. Root lies in the interval minus 1 to 0. So our next steps, we want to determine f dash x here. F dash x is equal to 5 x raised to 4 plus 5. So this is the value of f dash x, and root lie in the interval minus 1 to 0. So now we want to select here x0. So for step first, we select x0 is the mid value of this interval, so minus 0.5. And the x1 can be calculated by using the formula, Newton-Raphson formula, x1 equal to x0 minus f of x0 divided by f dash of x0. So x1 is equal to x0 is minus 0.5 minus f of minus 0.5 divided by f dash of minus 0.5. So it is equal to, x1 is equal to minus 0.5 minus f of minus 0.5. So what is f of x here? X raised to 5 plus 5x plus 1. X raised to 5, x raised to 5 plus 5x plus 1 plus 5x plus 1 divided by f dash of x. What is f dash x? 5x raised to 4, 5x raised to 4 plus 5. So 5 minus 0.5 plus 5, 5x raised to 4 plus 5. So it is equal to, if you calculate this, it is equal to, x1 is equal to minus 0.5 minus 1.5312 divided by 5.3125. So x1 is equal to minus 0.2118. So this is the value of x1 by using first iteration. Now x2 is equal to, for x2 is equal to step number 2, x2 is equal to x1 minus f of x1 divided by f dash of x1. So it is equal to minus 0.2118 minus f of 0.2118 divided by f dash of minus 0.2118. So it is equal to minus 0.2118 into f of x. What is f of x? X raised to 5, x raised to 5 plus 5x plus 1. So x raised to 5 means what? Minus 0.2118 raised to 5, x raised to 5 plus 5x minus 0.2118 plus 1 divided by f dash of x. So f dash of x is what? 5x raised to 4 plus 1. So 5 minus 2.118 raised to 4 plus 5. So this is equal to, x2 is equal to minus 0. If you solve this, minus 2.1, here I am writing minus 0.2118 minus 0.0592 divided by 5.01 01, so it is minus 0.199. So x2 is equal to minus 0.1999. Now x3, now you can see here the x1 is minus 0.2118 and x2 is what, minus 0.1999. They are not correct up to single decimal places. So next step number 3, x3 is equal to x2 minus f of x2 divided by f dash of x2. So x3 is equal to x2 minus 0.1999 minus f of minus 0.1999 divided by f dash of minus 0.999. So this is equal to x3 is equal to minus 0.1999 minus f of 0. That is x raised to 5. If you solve this x raised to 5 and f dash of it, we get here minus 0.1999 raised to 5 plus 5 times minus 0.1999 plus 1 divided by f dash of 0.5 minus 0.19994 plus 5. So this is x3 is equal to minus 0.1999 minus 0 divided by 5.008. So this implies x3 is equal to minus 0.1999 minus 0. So this implies x3 is equal to minus 0.1999. So you can see here these x3 and x2 are correct up to 4 decimal places, and therefore since x2 and x3 correct up to 4 decimal places, and therefore what is the root of this, real root of the given equation is, and therefore root of the given equation is equal to minus 0.1999. This is the answer of the given equation. The last example number 4. Using Newton-Raphson method, find the value of the following. Using Newton-Raphson method, find value of under root 10. What is the value of under root 10? Now we assume here the value of under root 10 is equal to x. So this implies x square is equal to 10, and this implies f of x is equal to x square minus 10. So this implies f dash x is equal to twice x. Now f of 3 is equal to 9 minus 10, which is equal to minus 1, and f of 4 is equal to 16 minus 10 is equal to 6. So f of 3 is less than 0 and f of 4 is greater than 0, and therefore root lies in the interval 3 to 4. Now we can select the initial root which lie between 3 and 4. So for step first, we select here x0 is equal to 3.2. Now then if we select x0 is equal to 3.2, then what is x1 here? x1 is equal to x0 minus f of x0 divided by f dash of x0. So x1 is equal to 3.2 minus f of 3.2 divided by f dash of 3.2. So x1 is equal to 3.2 minus f of 3.2. So what is f of x here? F of x is x square minus 10. This is f of x here. We assume the root of the given equation is x, so x square 10, and f dash x is equal to what? Twice x. So here x square minus 10. So it is 3.2 bracket square minus 10, and f dash 10 is twice x, so 2 times 3.2. So if we solve this, x1 is equal to 3.2 minus 3.2 bracket square minus 10, it is equal to 0.24 divided by 6.4. So x1 is equal to 3.1625. This is the value of x1. Now x2 is equal to, next step number 2, we assume x2 is equal to x1 minus f of x1 divided by f dash of x1, and therefore x2 is equal to 3.1625 minus f of 3.1625 divided by f dash of 3.1625. So it is equal to, x2 is equal to 3.1625 minus, what is x, f of x, x square, 3.1625 x square minus 10 divided by twice x, so 2 into 3.1625. So if we simplify this, x2 is equal to 3.1625 minus 0.0025 divided by 6.325. So x2 is equal to 3.1623. x2 is equal to 3.1623. Now you can see here x2 and x1. What is x1 here? 3.1625, 3.1623. So they are correct up to 3 decimal places. Now if you try to find the next iteration, you will get the root correct up to 4 decimal places. So here step number 3, x3 is equal to x2 minus f of x2 divided by f dash of x2. So x3 is equal to 3.1623 minus f of 3.1623 divided by f dash of 3.1623. So it is equal to, x3 is equal to 3.1623 minus, what is f of x? It is x square, 3.1623 x square minus 10 divided by twice x. Twice x is what? 2 times 3.1623. So if we solve this, x3 is equal to 3.1623 minus 0 divided by 6.3246. So it is equal to, x3 is equal to 3.1623 minus 0. So this implies x3 is equal to 3.1623. So this is the root of the given equation, x3. Now you can see here x3 and x2 are correct up to 4 decimal places. x2 and x3 correct up to 4 decimal places, and therefore here the root of the given equation is equal to 3.1623.